Welcome to lesson 9.3 on area of composite figures. And how do you find the area of composite figures? Well, we're going to figure that out. In this explore activity, we have Aaron, who's plotting the shape of his garden on grid paper. So he's planning this garden here. While it was an irregular shape, so it's not like a clean rectangle or square or something, it was perfect for his yard. Each square on the grid represents 1 square meter. So what that means is this represents 1 meter, this one represents 1 meter, and that square represents 1 square meter. So one way you can find the area of this garden is you can divide it into rectangles and triangles. Use a formula to find the area of each and then add up the areas together. So the area is 46. So what we can do is let's see. We could have this. Well, I think that, I got another way to do this too. I could do this. Well, I won't do that. I'll be really kind here and I'll just say, well, we have rectangles and we have triangles right there. There's 2 right there. So this is a distance of 1, 2, 3, 4. So that's 4. And this is 2. Okay, this distance is 1, 2, 3. 3. This distance is 1, 2, 3, 4, 5, 6, 7, 8. So that's 8. So we have an area of 4 times 8, which is 32. That's the area of that. And 2 times 3 is 6. So 32 plus 6 is 38. Okay, so we have an area of 38. I'll put that over here. 38 plus the area of the triangle. The area of the triangle is going to be the distance, the base times the height divided by 2. So that's 8 times 2, which is 16, divided by 2 is 8. And 38 plus 8, there is the 46. Okay, now compare what you did with other students. So I didn't have other students, but I'd like to discuss other methods. You could count all the squares. You could just count them up. Count up all these squares here individually and know that you have some half squares that combine to give you complete squares. Or another method is rearrange the triangle to be a rectangle to find the area and then add the areas. So what you could do is you could take this part right here and you could put it on top and you could put it right here. And then you would see that, you have another rectangle right there and you have 3 rectangles. So that's another way of doing it. So what we have is how does the area compare? Well, all the methods will arrive at the same answer. And use dotted lines to show 2 different ways that he could divide up this garden. Well, you can do it this way and this way, where you have a triangle, 2 rectangles. And you can have, actually, that's the exact same that I did right there. And you can have this way here, where it's a triangle and 2 other rectangles. Or maybe instead of that, what I could do is I could take the area of this whole thing here and subtract that area right there. So maybe that's what I'll do. I'll do that, but this is expected to be subtracted. Okay, so and the whole idea here is of composite, area of composite figures. A composite figure is a figure that's made up of several different shapes. So we have triangle and rectangles here. Now, find the area of a composite figure. It's made up of several geometric shapes. To find the area of a composite figure or other irregular shaped figures, you divide it into simple non-overlapping figures. Find the area of each simple figure, then add the areas together to find the total area of the composite figure. So we have this review here, and this is back from 6th grade, where the area of a triangle and square, rectangle, parallelogram, and trapezoid. And we're going to use these areas to find the areas of these more complex shapes, breaking them down into each, some of these here and adding them together. So here, to find the area of this figure, I would say we have a parallelogram up top. I'll zoom in a bit here. So we have a parallelogram here, and we have a trapezoid. So the area of the parallelogram. So this all these measurements here are transferred to here. To find the area of a parallelogram, we need the base and the height. We don't need that side right there. That's a distractor. So we need the base, 10, and the height, 1.5. And we know it's the height there because base and height meet at 90 degrees. This is also 10, and this tells you that it's meeting at 90 degrees. Okay, so you just multiply those two numbers together. 10 times 1.5 is 15. So the area of the parallelogram is 15. The area of the trapezoid. Now the area of the trapezoid, we need the base. And as we have our two bases, we have 7. And then the other base was 10. And I know that that length is 10 because these two lengths are the same. Right here. And this is this dotted length here. That is 10. So I'm going to write that 10. And what I'm going to do is I'm going to follow this formula here. Half base time, half times the height of the trapezoid plus the sum of the two bases. So base 1 base is 7, the other base is 10. Okay, the height is 1.5. And now we use those three measurements. 1/2 height is 1.5. 7 plus 10 are the two bases. So we add those two together and we get 17. And 1/2 times, well, we can call that 0.5 times 1.5 times 17 is 12.75. And so the area of the trapezoid is 12.75. So the total area of everything here is what? The 15 plus the 12.75 right here, which is 27.75. That's the entire area. And make sure you have the square centimeters label right there because we are talking about area. So going on to this, the your turn questions. I have this. I saw a rectangle and two triangles. So the area of the rectangle, so I'll call it rectangle, is what? 4 times, now this is 8, but that's not the entire length. What? 9, 10, 11. So the 4 times 11 is the rectangle, which is 44. The area of that triangle right there is 2 times 3 divided by 2, or 1/2 times 2 times 3. I really just divided by 2 instead of multiplying by 1/2. And I can see that these 2's would cancel, and that is 3. That's the area of that one. So triangle 1 and triangle 2 is, I'll just have a colon to separate that. Triangle 2 is 3 times 3 divided by 2, okay, which ends up being 4.5. So I just did 9 divided by 2, 4.5. Now I have to add 44 and 3 and 4.5, and I add those three up, 51.5 square feet. Now for this one, this is I see a square and a semicircle, or half of a circle. Square is going to be easy. That's 10 times 10, which is also written as 10 squared. That's 100. Now the area of the semicircle is half the area of a circle. Remember, the area of a circle is pi, oops, can't see that, is pi times the radius squared, but I'm taking half of that. So half of that is pi times the radius squared divided by 2. So I'm going to use this over here, pi times the radius squared. Now, the entire distance is 10, because I see it there. Half of that is going to be 5. Well, 1, 2, 3, 4, 5. So that is 5. So I'm using pi right here. Pi times the radius squared, 5 squared. But you have to divide it by 2 because you're taking half. You don't need the entire circle. And 5 squared is 25. So 3.14 times 25 is 78.5. And you got to take half of that, which is 39.25. So now I add my 100 plus the 39.25 to get the total area of 139.25 square meters. All right, so we're going to use our new skill to solve some problems, such as a banquet room is being carpeted. Floor plan of the room is shown at right, so it's this irregular shape here. Each unit represents 1 yard. Okay, so that means that this would be 1 square yard. The carpet costs 23 per square yard. How much will it cost to carpet the room? Okay, so we got to separate this into different shapes. And Looks like they have a parallelogram, that parallelogram there, and a rectangle and an itty bitty triangle right there. So we are going to get the parallelogram, and the parallelogram looks like it's going to be 1, 2, 3, 4. So the base is 4, and the height is the distance between the bases, which is 2. So you got 4 times 2, which is 8. The rectangle, that's going to be easy. 1, 2, 3, 4, 5, 6, and times 1, 2, 3, 4, and you have 6 times 4 is 24. Okay, there's the rectangle. And then the triangle, base times height. Base is, where are we? Base times height. So that's 1 unit, and this is 2 units. So base times height, 1 times 2, 1 times 2, 1 times 2, but you got to take half of that. So 1 times 2 is 2, and half of that is 1. So you have to add up. We're going to add up all 3 of these, that, and that. So add them all up, and you have 33 square yards. So that's how many square yards you have, but it's $23.50 for each square yard. So you have to multiply them, and you get $775.50 is the cost to carpet the room. Okay. So I'm going to apply that to this. A window is being placed with tinted glass. The plan at the right is the design of the window. Each unit length represents 1 foot. So each square is 1 square foot. The glass costs $28 per square foot. How much will it cost to replace the glass? Use 3.14 for pi. Okay. So what I saw is a rectangle and 2 half circles, which really just make 1 entire circle. So my plan was I'm going to find the area of the rectangle plus the area of a circle. The rectangle is 4 times 5. This distance is 4, and this distance is 5. So you multiply 4 times 5, and this rectangle area is 20. The area of the circle is pi times the radius squared. So pi, okay, 3.14, and the radius squared. The radius is really just this distance here, which is 2, and you have to square that. So 2 squared means 2 times 2, which is 4. Okay. Before I can add these together, I have to multiply 3.14 times 4 because you have to follow the order of operations. That's 12.56. And now I have to add the area of the rectangle plus the area of the circle, and that's 32.56. That's the area. That's not our final answer. Remember, we're supposed to find out how much it costs. So the area times this cost per square foot gives us our final cost, $911.68. And so that is the use of area of composite figures and solving those problems involving composite figures.